there are some slides that we can sort of skip because they are explaining pretty much exactly the same principle. But in this particular case, let's say you've got a variable and the variable's value is 10, for example. So if you are writing to a file, then it's just the actual value that you'll be transferring to the file. So in this particular case, you have 10 being transferred to the file. So if you write them sequentially, you're going to get more content transferred to the file. Reading from the file, you're just reading the content into a variable. It's just like passing functions and other things as well. So please, if it gets too quickly, let me know and I'll slow down. File being a collection of information, we play with files all the time, saving video files and all those kind of things. So basically, collection of information stored on a disk, or that's stored in the storage, I would say, not necessarily in a disk. And of course, the information can be saved in the file and then for later use. Files are given names. So this one, we don't necessarily need to go into it because you need to be able to identify the file in order to either read from it or write to it. So in this particular case, we need to include the right header that will allow us to do the file streaming in terms of reading or writing to a file. So in that case, you need to include the F stream, similar to what we did for strings, for example. Okay, so for outputting to a file, we use the output file stream or OF stream, or for inputting from a file, or then in that case, we use the input file stream, or you can use the file stream to do both. So basically, before we can write to the data, think of the input file stream as sort of a class, for example. If you think of it as a class or data type, then you need to create a variable of that data type. If it is a class, you're creating an object of that particular class. If it is a structure, then you're still creating a variable of that particular structure that you have created. Or if it's a template, you're just creating a variable of that. So basically, just what this means is that we are creating a name or a certain variable which we will call the input file, or certain objects which we will call input file. It's just a way of understanding it. So that input file will give us access to the functions available to the input file stream, and on there we can do an open, and then we'll give the name of the specific file that we are trying to open. For the online compiler, this is sort of enough because we don't need to go through all the way to the path of that the particular file to find it. Otherwise, if the file is located in a different place, in this particular case, like drive D, for example, then you can go to drive D and then find the particular name of the file you want to open. Alternatively, you can use the dot operator, which will give you access to a way that you can just simply find a file from the home directory, for example, if that is sort of giving you access to where the file is stored. It's just basically providing the path to the file so you can get access to read from it. But then if you look at the example which we have out here, we've got the file IF stream. So we've got IF stream and then the file name. So in this particular case, the file name is fen. Please remember C++ is case sensitive, so this should be small I instead of caps. Right, why use file handling? Writing, reading from a file gives you storage. We make use of other things. So I'll go through these key steps that you need to follow when it comes to handling files. So basically naming the file, opening the file, reading from the file, writing to the file, and then closing it. Remember, when you close the file, you open a file, you need to definitely close it. Otherwise, you make use of too much memory. And we skip the bits that are, I think, a bit repetitive. But if you go into what are some of the functions that are available to you when it comes to handling files, so basically, we can have the dot open. I think we used it here. So we've got a dot open where we are opening this file. And similar to that, so you've got to open and you can use close to close the file. You can use get to get a character from the file. So you're looking for a particular file character that you want to grab from the file, or you can use put to send a character to the file. Then you can read from the file, and then of course write to the file as well. Just have to put the right syntax and other things, okay? So in terms of defining the file, we've similar to what we did for the input file stream, you do the same for the output file stream. So output file, and then we're looking at the name of the file we want to output to, right? And then we can open that file. After that, we create that output file. We can read, we can, of course, open the file. In the particular case, we are, of course, connecting it to data1, which is the name of the file that we are opening at that point. And when we are done, we need to close it. So we're looking at the modes in which we can actually open a file, for example. So when we open a file, we can say we want to write to the file. In that case, it's open for write access. Or we can open the file as a read-only file, meaning definitely you can't write to it at that point. So you remember you have several read-only options when it comes to, actually, if you download, I think, a Word document from the online, or you open it from an email, for example, it's normally opens in a read-only mode. It means you can't edit it unless you save it, and then you can make editing to it. Or you can append to it, meaning that you can add content to the end of the file. Or you can open the file. It's similar to the appending, but using the AT option. You notice this dot dot operator is similar to what you do for the std dot dot. So that gives you access to a particular function to use anyway. So this will take us to the end of the file when it is open. Right, so this one, append for the data, will give you access to appending to the data. In terms of examples, so we have an F stream, and we've called a file. We have a file open for both reading and writing. So in this particular case, it's, well, input file stream or output file stream, but we are using F stream, so they give us access to both of them. So when we have the file, we open the file, and it's giving us options that we can pass to the file. So the first one that we pass, it's like normal functions, right? Is the actual name of the file itself. So we've got the object and the actual name of the file itself, which is data.test. And in this particular case, we are opening data.test with output options. So we can actually write to the file, and then also we're giving it input options so we can actually read from it as well. So it's just basically read-write mode that we are opening this file as. So similar to what we have before, we say, okay, the data can be written anywhere when we open this one, so we can write at any point in time, at anywhere on the document. And then the append is appending to the end of the file. Let's say if you were creating your receipts for the assignment you are doing, so you can just keep appending to the end of that particular file, the receipt once you make a stock, for example, those who are talking about stock. Anyway, so for read-write of binary data in binary format, ones and zeros, you can just use this option to read binary files. And I think the only thing that actually stands out is the truncate option, where you can actually discard the existing content.